Okay, so here goes around. This is my third attempt at this, so I hope this works this time. Okay, so I got partway through and it shut down on me twice now. So anyway, so let the P4 of x is this Taylor polynomial of order 4 for the function of f of x at x is 4. Assume it has derivatives of all orders for all real numbers. So first we want to find f of 4, which essentially means that f of 4 is approximately equal to P4 at 4. And when I plug in 4 everywhere, these are all 0, and you're left with just 7. So the second one wants us to find the third derivative of f, approximation for it, and that's approximately equal to the P4, the third derivative of that, of x. Okay? But I want to remind you that when we're doing the third derivative, the only term that matters is that third degree term. Okay? And the reason for that is this will be gone after the first derivative, after the second derivative, after the third derivative. This will be left, and there'll still be an x minus 4 here. When I plug in 4, that will also be 0. So the only term that matters is this, and we need to differentiate this 3 times. Okay? So we start with this. After the first derivative, it's going to be negative 2 times 3, and then that's going to be to the x squared power. The next derivative is going to make that a 2 there, and then it will be x minus 4 to the first power, and then the last derivative is going to give me a 1. So that is the value of it at any value, which happens to be also at 4, which I get negative 12. Okay, so just so you understand this too, if we would ask to find the fourth derivative at 4, the only term that would matter would be this one, okay? And I'd have to take 4 derivatives of that. So I'd start out with a 6 in front. After the first derivative, I get a 4. Second derivative, I get a 3. So third derivative, I get a 2 and then a 1. So that is 6 times 24, which happens to be 144. Doesn't matter where this happens to be centered because it's just a constant, okay? All right, so question B says write the second order, which is the P2, Taylor polynomial for f prime at x is 4, and then we're going to approximate this. So let's first find f prime. So f prime of x is approximately equal to the P4 prime of x, which is, this is gone, so I get negative 3. Here I get a plus. If I differentiate that, I get 10 times x minus 4. That's a P1. We got to do one more. So I get negative 6 times x minus 4 squared. And that is my second derivative. That's my first derivative, but it's the P2. So now to find f prime at 4.3, that's approximately equal to the P4 prime of x. Now I'm just going to go substitute in 4.3, so I get negative 3 plus 10 times 0.3, because whenever I plug in 4.3, I'm going to get 0.3, minus 6 times 0.3 squared. Okay, so this is negative 3. This works out to be a positive 3, so they cancel each other out. And then this is negative 6 times 0.09, which gives me negative 0.54. Okay, so, and by the way, since f prime at 4.3 is negative 0.54, we could say the function is, since it's less than 0, it's decreasing. So we could be asked that. So what conclusion can we draw is the function is decreasing since the first derivative is negative. Okay? All right. So if we go on to the next one, it says write the fourth order Taylor polynomial for g of x. If g of x is the integral of f of t, and we're going to do it at 4. Okay? So first of all, we're going to say g of x is equal to the integral from 4 to x, and I'm going to write out each of those. So it's 7 minus 3, but I have to do them with t's in them. So it's t minus 4 squared minus 2 times t minus 4 cubed plus 6 times t minus 4 to the fourth dt. Okay? So we're now going to integrate each of these terms with respect to t. So I'm going to get a 7t minus 3 times t minus 4, and that's going to be squared now. Balance it with the 2 on the bottom. Plus 5 times t minus 4 cubed. Balance it with a 3 on the bottom. And I'm going to do minus 2 times t minus 4 to the fourth with a 4 on the bottom. Plus 6 times t minus 4 to the fifth with a 5 on the bottom between 0 or between 4 and x. All right, but I want you to notice here, this we're looking for the fourth order, okay, which means a fourth degree. So when I go plug in x, I don't need this one anymore. It's an extra term. Okay, I don't want to put any extra terms in there. But now we need to go plug in x, and then we need to go substitute in 4. So g of x will equal 7x minus 3 times x minus 4 squared over 2 plus 5 times x minus 4 cubed over 3 minus 2 times x minus 4 to the fourth over 4 minus, and I'm going to go plug in 4. Nice thing is I plug in 4, this is 0, this is 0, this is 0, and this happens to be 28. Okay? So that is what g of x is equal to. It's the fourth order of g of x at 4. Okay? All right, question D says, can an exact value of f of 3 be determined from the information given? Well, this is centered at 4, so the only place we can actually get an exact value would be at x is 4. So it is not possible to get an exact value at 3. So the answer is no, only exact at x equals 4, which is the center. So the center is the only place you'll get an exact value. Okay? All right. Last one is we gave a P3 of x. Nope, it's actually the P4 of x. For f of x, find the fifth order Taylor polynomial if g is equal to the antiderivative of t times f of t plus 3 dt. All right, so first of all, we got to find what f of t plus 3 is. Well, that's approximately equal to P4 of t plus 3. And what happens whenever I plug in t plus 3, this is just t plus 3 minus 3 is t. T plus 3 minus 3 is t. So you get 1 plus 2t minus 5t squared minus 4t cubed plus 9t to the fourth. Okay? All right. So now we still got to multiply through by t. So t f of t plus 3, I'm just going to multiply each term by t. So we're going to say that's approximately equal to P4 of, or t times that. So I get t plus 2t squared minus 5t cubed minus 4t to the fourth plus 9t to the fifth. All right, so now I can go integrate it between 0 and, or between 3 and x. Okay, so g of x will equal the antiderivative of t plus 2t squared minus 5t cubed minus 4t to the fourth plus 9t to the fifth dt from 3 to x. All right? So when I integrate this, I'm going to get 1ft squared plus 2/3 t cubed minus 5/4 t to the fourth minus 4/5 t to the fifth plus 9/6 t to the sixth between 3 and x. Okay, but I want to point out we're looking for the fifth order. So this was the sixth order, so I got to get rid of that one also. So my final answer, so g of x So I'm going to first go plug x in, so I get 1fx squared plus 2/3 x cubed minus 5/4 x to the 4th minus 4/5 x to the 5th minus, now I got to go plug in 3 to everything. Well, this is 1/2 of 9 plus 2/3 of 27 minus 5/4 of 81 minus 4/5 of 243. And if I work that out, I believe I have it, it's minus negative 5463 over 20, or plus, because it's a negative number, so subtract a negative, I get 5463 over 20, or which is also 273.15, which I said, hey, that's really close to Kelvin, isn't it? Anyway, all right, so that was our last one. Okay, I hope this helps. I hope we got this cleared up. I wanted to make sure we got a little bit of the Taylor review after we did endpoint work today. So, all right, thank you all, and have a great day.